In this video, we are going to discuss an implicit function and related derivatives. What is an implicit function? A function always kept in the form of f of x y is equals to c, where y is a function of variable x and c is a constant. Implicit differentiation. If fxy is equals to c is an implicit function, then differentiating both sides with respect to the variable x, and it gives dy by dx as negative fx upon fy, where fx is dou f by dou x and fy is dou f by dou y. Hints and tips. The student always ensure that dou f by dou y is non-zero value to estimate dy by dx. That is one of the very important tips regarding implicit differentiation. The student always used to get the implicit differentiation if y cannot be easily solved as a function of variable x. That is the second tip. Counterexamples. The first counterexample is based on circle equation, where circle equation x squared plus y squared is equals to 1. First, you can write implicit function fxy as x squared plus y squared negative 1. Then find dou f by dou x, dou f by dou y. Implicit differentiation negative fx by fy. On simplification, you get negative x by y. This is implicit differentiation regarding circle equation. The second example based on symmetric cubic curve. What is that? Symmetric cubic curve. The implicit function will be x power 3 plus y power 3 negative 3xy. Then find dou f by dou x, dou f by dou y. Implicit differentiation becomes negative of this expression. The next example is based on implicit equation involving trigonometric functions, where the implicit equation is y equals to sin x plus cos y. You can write the corresponding implicit function sin x plus cos y negative y. Then estimate dou f by dou x and dou f by dou y. Implicit differentiation regarding this equation involving trigonometric functions as negative fx upon fy. On simplification, we will get a cos x by sin y plus 1. The next example rely on exponential relation as well as quadratic relation. The corresponding implicit function is e power x plus y square negative 1. Then find dou f by dou x, dou f by dou y. Then implicit differentiation becomes negative e power x by 2y. The next example is based on polynomial relation, where the polynomial relation is x square y plus y power 3 is 4. The corresponding implicit function becomes x square y plus y cube minus 4. It is fxy. Then consider dou f by dou x, dou f by dou y. Then write dy by dx as negative fx by fy. It gives us negative 2xy by x square plus 3y square. The next example rely on hyperbola equation. We know that hyperbola equation y square minus x square equals to 1. The corresponding implicit function will be y square minus x square minus 1. Then consider dou f by dou x, dou f by dou y. Then implicit differentiation becomes negative 2x by 2y with negative sign. On simplification, we obtain x upon y. The next example is based on logarithmic and quadratic relation, where the logarithmic and quadratic relation is log y plus x square is equals to 1. The corresponding implicit function will be log y plus x square minus 1. Then find dou f by dou x, dou f by dou y. Therefore, the implicit differentiation dy by dx becomes negative 2xy. You can see the example which is based on product of squares. X square y square is equals to 4 is the relation based on product of squares. The corresponding implicit function is x square y square negative 4. Then find dou f by dou x, dou f by dou y. Therefore, the implicit differentiation will be negative y upon x. The next example is based on the cubic relation in y with a linear term x. So, y cube minus 3xy is equals to 0. You need to write the corresponding implicit function as y power 3 negative 3xy. Then consider dou f by dou x and dou f by dou y. The implicit differentiation negative fx upon fy, negative of negative 3y by 3y square, y upon y square is 1 upon y. Finally, you can see a higher degree polynomial relation x power 4 plus y power 4 is equals to 16. You can write the corresponding implicit function x power 4 plus y power 4 negative 16. Then write dou f by dou x and dou f by dou y. Then implicit differentiation dy by dx becomes negative x power 3 by y power 3. We have shown many examples regarding implicit differentiation.